Hey, what's up guys? Jeremy here. Let's say you need to machine a big part. Let's say a life-size statue. I bet you'll have a hard time finding any traditional CNC that can take on such a task. But a robotic station can handle it pretty easily. If you just have one robot, you can quickly just machine one side and then turn the statue and then machine the other side. It works, but it's a bit inconvenient. That's even better if you add to your setup a turntable where you can place your statue on, the turntable turns, and the robot takes care of the side in front of it. The thing is, the programming process for such setup gets much more complicated. This is if you don't use any software tool. And with RoboDK and the BobCAD plugin, the programming process of such application should run super smoothly. Let's get started. Let's start inside RoboDK. So I pre-created the station. So we have a robot, we have a pedestal, a tool, and a turntable. So the first thing you need to do is synchronize the turntable and the robot together. This is required so that when RoboDK generates the robot program, it makes sure to have the turntable at the right position for every move, and that both the turntable and the robot will synchronize their speed together to give you the best finish possible. So to do that, fairly easy. You right-click the robot, you select Synchronize External Axis. It will bring up this window here. You select under Turntable and Linear Track your turntable, in this case the KP1 V500, and you click OK. You will now have in your robot panel your 6-axis plus a 7-axis for the turntable. And here you will see a small kind of chain link showing that those are synced together. So that's great. Okay, now let's open BobCAD. So for this example, we have indeed a life-size statue. So the process is pretty simple from a machining standpoint. We'll just do a spiral from the head to the feet, starting from the top and going down. For the sake of keeping this example simple and for it not to take forever in terms of processing, we greatly reduce the number of points, and the passes are way too far from one another. We would recommend you to have a better, let's say, machining setup than that, or machining parameters than that, but this is just so that we keep the number of points relatively low to speed up the process. So if I use my little process here, my process scroll bar, I can go from the top to the bottom, and you see how the tool should behave along the path. So that's great. So I can leave the simulation environment. First, the thing we'll do is bring in our part. So I'll just go back to RoboDK and make sure that part is the frame activated. I will go under settings here, and I will enter under reference name the name part, which is where I would like the object to be loaded. I'll select load part. I'll wait a few seconds here, and my statue was loaded right on top of my turntable, which is awesome. So if I double click the robot and then rotate my turntable, the statue will move with it. So if I go back to BobCAD, so here we have the path. But the thing is, like, when you have to optimize a path using 7 and 8 and even 9 axis, which we support, it makes things a bit more complicated for RoboDK in the background. So calculation takes more time. So when you press update, it might take a few seconds to a few minutes. So what I recommend people to do is to isolate a section of their program. So in this case, with those little rectangle, I isolated the head, and use that section as their testing section here. So if I was to bring that up here, as you can see, I have kind of, let's say, a few lines in the face or around the head and up to the shoulder. So I'll take that section here first. I'll bring it to RoboDK to do the testing and the optimization. The parameters should be the same for the rest of the body, but that will speed up the process quite a bit, or speed up the iteration if I ever have to do settings iterations to figure out the proper settings. So I'll just click Update Operations, go back to RoboDK, close the robot panel, bring the robot machining project here. As you can see, if I come close, you will see the lines in green, which are the tool path, and then in white, the normal or orientation of the tool. So just here for the head, we have 2,300 points almost. So the first thing you will need to do is, again, same as before, move the robot into the starting position that you would prefer. So I would go for something like this, maybe. Perfect. I will move that here on the side. I will double click my robot panel. Here I created a turntable that has a lot of, let's say, degrees of rotation. We can't with RoboDK create a turntable that has infinite degrees of rotation, but you can double click here the limit and just add a very, very big number to kind of simulate that. So I'll just bring my turntable towards one limit, not exactly at the limit, but towards the limit. So maybe even a bit more than that. So just like this. And I will look here at my path from, I'll get a bit closer. And as you can see, it's kind of spiraling that way. So that means that I will have to spiral towards the negative values of my turntable, which is fine. So I'll go and I'll find like a starting point somewhere like that. That makes sense. I will create a target here. So if I need to go back, I'll just have to double click on it. I can make it invisible. Perfect. I can close this here. So what you will see is, like, compared to before we had the first day when we didn't have any external access, we didn't have those options here. So axis optimization and turntable optimizations. So both should work for that process. In this case, I will go for the smart optimization, but that turntable optimization should work because we only have one axis here. So what I will do is I will click on the teach here so that I kind of record this here. If I'll click on show preferred toolpath, in fact, I will click on the Z plus here first of all. In another video, I'll show you exactly what this does, but this pretty much just makes sure that the X-axis of the tool is aligned with the Z-axis of the robot base. And then I will use my scroll wheel to rotate the ghost tool that you see here so that the flange is always pointing towards the robot as much as possible. So that's great. Then I will click here to set the current position of the joints as my starting point, and I will open the optimization parameter window. So this here can be a bit frightening when you take a look at that, but what's most important is what we have here. So it's kind of recommended preset. So what do you want to keep? The flange orientation. Do you want to keep the flange pause? Do you want to keep the axis reference, or do you want to keep the external axis reference? Do you want to move more the external axis? Do you want to move more the robot? What is your game plan, in fact, here? So in this case, my game plan will be to keep that tool or flange orientation. I don't care about the position. It can go up, down, forward, backward. I don't care. But I would like it to be always in this direction here. So I'll go to keep flange orientation. It will apply the orientation here and say, okay, I would like to use this reference. And it will say, okay, you can move the turntable as much as you want, like that. So if I click this here, and I will remove the approach and retract motions, because as I said before, this is handled by the machining software, and I'll click update here. This will take a few seconds. It will take less time if you don't have optimization parameters, which I will certainly do for the bigger path. So optimization parameters help you will make you rotate around the Z-axis of the tool to avoid singularities, joint limits, or race limits. As we're using a turntable, those should already be avoided by the turntable, but in case. So now we have a nice green check mark here. So if I click simulate here, I'll see what the path looks like. So this is awesome. Great, so I can use the slider to move along. Awesome. If I reopen it here and I insert here, allow a Z rotation of, let's say 0, because I don't want to have any rotation to avoid singularities, then I click update, it's much faster. And in this case, it still gives me my green check mark. So that's very cool. Awesome. So I can stop that here. What I will do is right click here, more option, copy settings. So when I can apply it to the new set, of in fact, the new program I will bring in with all the statue finishing path on. So this one here. So I'll go back to RoboDK and then update operations. It simply updated the one we had before, kept the same values because the name was exactly the same. So that's cool. I can select update. This one will take a bit longer. If you have the optimization parameters activated, this will take several minutes. So if you can give it a try without the optimization parameter, so just with 0 here, that would be even better. Okay, wait a few seconds, updating, checking if everything is fine. There's 27,000 points to take care of. If I click simulate here, it will find my starting point, and then we'll rotate around the part like that. So I can fast forward that a bit here. Okay, great, awesome. I could activate the collision checking option if I feel the need, which I don't in this case here. The last thing I have to do is like right click this robot program here and then generate robot program, which will open VS Codium with our program. So as this program is very, very, very long and potentially does not fit onto the memory of the robot controller, it was automatically split into smaller pieces. So we have finishing machining and finishing machining 1, 2, and 3. So this is set up by a limit of lines in the post processor. It will simply call the next program at the end, and then so on and so forth. So that works very well to split up a program into smaller pieces that are more digestible for the controller, but you can change that option too. So that's pretty much everything for this tutorial. I hope it was helpful, that you can see how you can use BobCAD-CAM and RoboDK together to create a huge working envelope for your project. So that's good. And in the next video, I'll show you how to install the plugin and a few settings that you might want to play around a bit to just make sure that your experience is as good as possible. I hope it was helpful, and in any case, have a great day, guys.